Okay, welcome America, welcome Taylor Swift. We hope you enjoy the lesson today. We are going to learn the basics of Pythagorean theorem. So I kind of already gave you an introduction to Pythagorean theorem. We're going to do two problems, but before we do so, I am going to show you how to Google the geometry formula sheet if you ever need it. So you just go to Google and type in geometry SOL formula sheet and some images will come up. And you might see the 2009 one. If you scroll down, there's the 2009 one. One at the top. The 2016 one is the one that you need. The reason it says 2016 is because that was the last time that we changed our standards in geometry. So that's why it's called the 2016 formula sheet. But you'll see a bunch of formulas that we will use this year much later on. And there is a triangle. Whoa, that was late. There is a triangle on the front, but that is for the area of a triangle. We don't need that yet. Onto the back though, we have another couple triangles. And the one that we need for today is the right triangle with the A, the B, and the C. A squared plus B squared equals C squared. That's the Pythagorean theorem. I'd like for you guys to write the C squared first, just for reasons that are going to show up in a later unit. But it's the same thing. A squared plus B squared equals C squared, and C squared equals A squared plus B squared. So it's always there if you ever need it. So now we are going to move to slide 25. Okay, so slide number 25. We've got a right triangle. We are given the lengths of two sides. In this case, it happened to be the legs. We know that they're the legs because they form the right angle. And the side that we're missing is across from the right angle. So that's the longest side and also the hypotenuse. Are you with me? That's your C. So we write our formula, and everyone is writing this down. We plug in what we know. In this case, we know A and B. We don't know C. Should I put the X or should I put the C? What do you want? What do you think, Ryan?
C.
C? We'll leave it as C. One less step. Now, common mistake is to add the 6 and the 8 here. We have to first square those two numbers because of order of operations. So, C squared equals 36 plus 64. Now we can add those two numbers together. Another common mistake is to say the answer is 100. This is actually C squared. We need C. So to find C, we have to take the square root of both sides. The square root of C squared is C. Square root of 100 is 10. So the length of this missing side here is 10. How are we doing? Good? Lots of thumbs up, lots of thumbs up. All right, is anyone still writing this down? Please take your time, write it down, let me know when we're ready to move on. That is the easier type of Pythagorean theorem problem where you're given A and B. The next problem, you are going to be given C. Anyone still writing? Finished? Okay, clearing that out. Last slide. This slide, you have to be careful with this type of problem. Notice, again, we're given a right triangle. We're given the lengths of two sides, and we're asked to find the length of the third side. However, this 15 that we are given is across from the right angle. So that's your C. This is your A and B. I guess 9 is A because they told us this was B. They're interchangeable though. So I'm going to start again, just like I did the last problem. C squared equals A squared plus B squared. And I'm going to put the values that were given here. But the 15 has to go in for the C. If you don't put it in for the C, it's a very, very common mistake. They do this on the SOL every year, and if you, by accident, put the 15 in for A or B, you can guarantee your answer will be one of the distractor answers, because it's just a common mistake. I've done it before, okay? So now, 15 times 15 is 225. This is 81 plus B squared. Subtract your 81. So now, what is that? What's 225 minus 81? And by the way, I do have a calculator at the top here, which let's just go ahead and, oh no, I can't use it because I'm gonna annotate. So somebody else use it. What do you get? Ryan? 144. I love it. That's a perfect square. Now when I take the square root of both sides, the square root of b squared is b, square root of 144 is 12. And then I check to make sure, does that make sense? That does make sense, because the two legs have to be shorter than the longest side, which is C, which is 15, and 12 is shorter than 15, so we are good. Are there any questions? This is the more difficult type of Pythagorean theorem question. Going once, going twice. Sold. All right,